Welcome to the Green Building Show, where we investigate green design and building trends throughout Australia.
Hi, this week we continue our investigation into the carbon neutral home. I sit down with Matthew Parnell, a sustainability consultant, to find out where the carbon is in a home and what can be done to reduce it. And later, I'll catch up with Francis Burke, a Fremantle-based developer who's built a home so sustainable that it's been accredited as carbon positive. Victoria, what have you got for us this week?
Carlos, okay, this is a bit odd, but what I want to talk about this week is something that's in our house every day we look at, and I as a mother sometimes use 5 times a day. It is the dustpan and brush, which I personally find to be one of the most ugly items around, right? And I use it a lot. So it got me thinking, can the dustpan and brush ever be art? Okay, so I looked around a bit. The Museum of Denver in the US has this giant, fabulous sculpture outside, the wonderful giant dustpan and brush. And then I got to Googling, and I think I have found what I think is the most beautiful and also eco-friendly dustpan and brush in the world. It is made by a Japanese designer, Oji Masanori, and sold through Analog Life online. And it's made of paper coated with a natural tannin, so it's beautiful and eco. Another fabulous one is, it's called the Giant Dustpan and Brush. It's sold through the UK website Labour and Weight, and it just pulls on that classic industrial inspiration. It's fabulous. Or if you want to get a little bit colourful, the folks at Alice Supply Co just sell these gorgeous kitschadal numbers, which are also really cheap. If you're in Oz, you want to go to top3design.com.au, fabulous website, and buy through Australia. They've got 3 brilliant products on there. They're all actually European, and none of them are Australian made, but there's some absolutely gorgeous ones there, the kind of things you just don't want to put away under the sink, you actually want to display. I don't know, I think it's just an ordinary everyday object that some of us have to use so often, and I just wish it could be more beautiful.
Amanda, what ideas have you stolen this week?
Well, Carlos, it's pretty simple, but as any really well-dressed woman will tell you, it's all about the detail. And so when I walked past this particular place, I couldn't help but noticing that they just did a really couple of interesting things to make their eaves look more interesting. I know that might seem a little bit weird, and actually people could look at the last issue of the magazine where we did a whole What's Hot feature on all about eaves. But what these people have done are really 2 key things. They clad the underside of their eaves not with anything that was just kind of white and boring. They actually put really nice like timber panelling under the eave, and then they clad along the side of it, along the barge board, with some express jointed panels painted in a really rich colour, and the whole thing just really made the eaves and their little back addition so much more interesting. Definitely an ideal anybody could steal.
Welcome to the second instalment of our Carbon Neutral Home series. This week we talk to Matthew Parnell.
Okay, so I'm here with Matthew Parnell. You're an energy, or you're a
sustainability consultant is the term.
You work with Green Synergies?
Yep, or Green Synergy Consulting, a small mobile consulting operation based in Coffs Harbour, but also work out of Sydney and all over the place, basically.
Fantastic.
Yeah.
Well, thank you for being with us, Matt.
Yeah, it's a pleasure.
So please tell us, what exactly is a carbon neutral home?
Well, a carbon neutral home is probably a growing definition, and people that are enthusiasts for this kind of home are probably making up their own definitions. But essentially, it's a home where, at its greatest extent, the materials, the way it's built and the way it's operated is not generating any additional carbon into the atmosphere. How you get to that point where you can claim it, there's a lot of different pathways.
Okay, and in an existing home which has already been built, where is the carbon?
Well, you could say that all the existing materials have probably paid back their embodied energy investment if they're sort of more than about 10 or 15 years old. Mm-hmm. But for those kinds of existing homes, it really gets down to the appliances that are plugged in using energy, or if they're on gas, the gas that they're drawing, or if they're even using sort of other fossil fuels for heating and so forth. So it essentially gets down to the activities of the people in the house and how they operate it.
Okay, fantastic. And what are some of the biggest offenders in terms of carbon footprint in a home?
Air conditioning, first and foremost. It's the single biggest reason why in New South Wales we can't cope with peak demands with our current generating power stations and so forth. It's one of the reasons why we actually needed to have a solar program to deal with peak energy. So air conditioners are probably the biggest fault, because they're often put on houses that are poorly designed and poorly insulated, and they're working extra hard, or they're much, much bigger than they need to be, or used more than they need to be. So air conditioners is the major one, and that's for heating and cooling. Then also our refrigerator is the main source now. Many houses don't just have one fridge nowadays, they have several, and often the worst offenders is that extra fridge out in the garage that's got a 6-pack in it, and it's just chugging away there, and it's usually a very old fridge, so it's not efficient, not being efficiently used, and not necessary. So those things should be turned off.
Okay, fantastic.
And then probably after that, lighting is one of the other things. Pool pumps as well. If you've got a swimming pool, that's a big source of energy usage in the place. So,
okay.
Yeah.
And when it comes to energy efficiency versus zero carbon and carbon neutral, these are two terms which I guess consumers hear quite often.
Yep.
What is actually the difference between star rating and carbon neutral?
Well, yeah, these terms do get conflated. When it comes down to energy efficiency, that's really about how you design a house and the types of appliances you select for the house and how you operate it. You can be carbon neutral by just doing nothing in your change of behaviour in the house, and you can just purchase carbon offsets from a carbon offset company. So you've not changed anything. All you've done is hope that someone has planted trees somewhere else to offset you, and you have done nothing. So I think that energy efficiency is the first step to being carbon neutral. So you reduce your demand on a system as low as you can by good design choices, good appliance choices. Then when you've got an efficient lifestyle and you still want to maybe offset, then you can go to a pathway where maybe you invest quite heavily in a solar system on your house that covers all your needs, or you then go and look for offsets. So that would be for the existing homeowner. Obviously, if you're designing a house from scratch, you've got many more opportunities to maximise your energy efficiency, to integrate solar systems and other renewable energy systems to reduce your carbon footprint without having to go to offsets or anything like that.
And so I guess, in your opinion, for a sustainable-minded homeowner, or perhaps even perhaps in the design stage, is carbon neutral a realistic goal for them, or should they be aiming for energy efficiency ratings first and then perhaps moving on to carbon neutral?
Definitely energy efficiency ratings, because some of the houses that are being put forward as carbon neutral, they're making big investments in quite sophisticated technologies and in solar. So for example, typically people are putting at the moment on their houses a 1.5 to 2 kilowatt solar system. You really need to be looking at a 6 to 10 kilowatt solar system to completely cover even an energy efficient lifestyle. So that's a bigger investment, and it's a question of whether people want to make it. And it's the same thing when it comes to the star ratings, because you asked me about that and I didn't sort of properly answer that. The star ratings are they get confused as well. Star ratings are a measure of the amount of energy a house requires to keep it comfortable summer and winter. Right, so there's an assumption that a certain house with a certain star rating will need a certain amount of energy input from artificial heating or cooling. So the closer you get to 10 stars, the less is the requirement. And there's a few people making claims now about 10-star houses, and in some climates that is quite possible. Other climates, very, very difficult to achieve. So the nature of thermal design of buildings, certainly in, for example, in the mild climates, where I'm in Coffs Harbour, for example, and up into Queensland, we actually get given a very, very small energy allowance because of the climate. And we can have a hard time getting much beyond about 7 stars to 8 stars, you know, under any arrangement of materials, because you get to a point you can't add any more insulation. It doesn't affect the numbers at all.
The homeowners, they can't assess accurately what the embodied carbon of the home is. But what can they do during the construction stage to ensure their carbon footprint of their home is as low as possible?
Do you know what I think is the simplest thing? And most homeowners, people building new houses, do not want to hear anyone tell them this. Their houses are too big. Pure and simply, I think if we want to actually reduce the embodied carbon impact of our building materials, instead of worrying about whether a stick of timber versus a bit of concrete's got these different embodied energies, I'd say think about whether you need a 350 square metre house or a 400 square metre house, and maybe think about getting below 200 square metres, and don't worry too much then about the embodied energy, because you've halved the amount of materials that you've used. You know, this is where we can get a bit carried away with, you know, carbon neutral, and I've seen, you know, 9-star houses, but they're 400 square metres, and my currently unrenovated 1950s era 100 square metre house in Coffs Harbour would probably be, if I rated it, it'd be less than a star. But I would use way less energy than a new 9-star house that's 400 square metres or something like that. So this is where it can get a bit ridiculous. So I think if people are really serious about it, I'm really not happy seeing people promoting greenhouses and carbon neutral houses that are really, really big.
I'm here today with Francis Burke. He's Director of Earth Care, a developer in WA's Fremantle, and we're talking about 58 Stevens Street. It's a development of 4 dwellings, also in Fremantle. Just tell us, Francis, how did this project come about and what makes it so sustainable and energy efficient?
Well, firstly, we lived at the site for about 10 years, my partner and I, Louisa, and it's a large site on the fringe of Fremantle, which is an old, but quite a location that sort of supports innovation. So we thought that if we were going to build a sustainable project, this would probably be a good location in terms of the sort of product and the sort of people who would be interested in such a product. I mean, it is a high quality project, and in regards to sustainability, my approach to sustainability is really just to tackle it from a multitude of ends. So we reuse some of the material from the site. We reused the existing house that was our house for a few years. So the cement blocks were reused and crushed, turned into essentially a road base, which we then mixed with cement and used for the rammed walls. So the rammed walls are 100% recycled material. The jarrah floorboards from the original house were reused, and then throughout the construction of the project, all of the materials were reused for processing. So from a recycling point of view, it's at a sort of a high end. In terms of all the houses are north facing, so we did things like thicken the concrete which picks up the winter sun, so that we get the sort of increased thermal effect. All the windows are E-rated, so they have a better ability to retain the heat and coolness. We use, as I said, recycled materials wherever possible. We looked at the life cycle analysis quite strongly. Some of the decisions we made include, originally there was solar hot water systems for each of the houses, along with 1.5 kilowatt PV cells connected back to the grid. We decided to basically just use instant hot water gas system, do away with the solar system, and increase the amount of solar panels. The landscape is very low water usage. We've got rainwater tanks plumbed back into the toilets and bathrooms. And I think the other main thing is using materials. It was a lightweight frame construction, pine timber with steel and also composite lightweight concrete cement cladding, which is quite interesting because that was unpainted. So from a life cycle point of view, there's essentially no maintenance on this place, on these houses, and it was one of the attracting features for it from the sort of people who ended up buying it.
Now it's time to take some questions from our readers and viewers. And our first question this week comes from Sheila, and she's asked, what's the best way to drain a 2-acre boggy block so that it's suitable to build on? Well, Sheila, your first call should be to a hydraulic engineer. They're the ones with the specialist skills to handle just about any drainage issue on a residential property. Our next question is from Jessie, and she's asked, what size should her west-facing windows be in order to improve her energy efficiency? To help us answer this one, we got in touch with Clinton Cole, our Light Home ambassador, and he's written in with his response.
Smaller windows on the west are preferable to reduce the heat load from the afternoon sun. Alternatively, deep eaves and shading devices should be employed when west-facing windows are essential. High-performance glazing that lowers the heat gain through the glass would be an added long-term benefit but will increase the cost up front.
Amanda's here to answer our final question, which comes from John. He's asked us to compare structural insulation panels with traditional wooden framing. Amanda?
When you think of building a house normally, yes, you're right, you have the frame and then you've got to put the outside wall on and then you've got to put insulation in and then you've got to line the inside wall and then you've got to go and paint the whole thing. Well, really a SIP is like an all-in-one wall, and so it's a layer of foam and it's sandwiched between 2 layers of board, so it's like a whole wall gets dropped into place. It's used a lot in the United States. They have quite a high proportion of usage of SIPs, and people think that because of the foam and also the fact that it's an all-in-one wall, that it gives you a lot more thermal efficiency, but it also makes it a lot easier to construct, or much faster to construct with. We actually did a little article on this in the autumn issue of Light Home magazine, and people could go back and have a look at that. But essentially we looked at a small project that was done for the Department of Housing in Western Australia, and they use SIPs.
Tell us about this Western Australian project. What was their experience with SIPs and how did they benefit?
Well, really the key benefit was in saving time. In fact, they say that it cut the construction cost in half and they saved about 16 to 20 weeks. Michael Roberts, who was the architect on that development, says that the other thing about SIPs is that they're really good for construction that's in a regional environment, because the walls, the entire wall, can be basically trucked to site and then installed and uses very little additional trades.